This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 2, Bearings, Life, and Selection. Lesson 1, Size the shaft and its key by stress against strength. The bearings that carry that shaft fail a different way. They don't yield. They wear out over millions of revolutions. So they're sized by a load versus life curve, not a single stress. We'll build the rating life law, fold an axial thrust into an equivalent radial load, then contrast the rolling bearing with the fluid film journal bearing. Concept 1. The rating life law. A bearing is rated by the load at which 90% of a batch survives 1 million revolutions, the L10 life. From that, the load life law. The required rating equals the load times life to the 1 over a power, with life measured in millions of revolutions. The exponent is 3 for balls, 10/3 for rollers. Turn it around, and life rises with the a power of the load margin. For balls, that's the cube law. Double the load, 1/8 the life. The same relation scales a catalog bearing between any two operating points. Concept 2. A combined load. A ball bearing often carries a radial load across the shaft and an axial thrust along it. You can't drop the radial load alone into the life law. First, fold both into one equivalent radial load, x times v times the radial, plus y times the thrust. V is the rotation factor, 1 for a rotating inner ring, 1.2 for a rotating outer ring. And watch it. V rides with the radial term and also sits inside the thrust test, so nail it down first. Concept 3. The thrust decision. Everything turns on one threshold, E, computed from the thrust ratio against the static rating C0. Then compare the thrust ratio FA over VFR to E. Above E, the thrust matters. X drops to 0.56 and Y comes from the printed power law. At or below E, X is 1 and Y is 0. The equivalent load is just V times the radial, and the axial rides free. Copy those constants and exponents exactly. They're built for deep groove ball bearings. Concept 4. The other bearing. A journal bearing is a shaft riding on a thin oil film inside a bushing. No rolling elements, so no L10 fatigue life. Instead, the Handbook gives Petrov's law for the lightly loaded case. The viscous torque, the frictional torque, the coefficient of friction, and the bearing pressure as load over the projected area. One caution that catches people. Petrov's speed N is in revolutions per second, not per minute. Setup. The worked problem. A deep groove ball bearing with a rotating inner ring carries 1,500 pounds radial and 500 pounds of axial thrust. We're given its static rating and a target life of 5,000 hours at 1,000 RPM. Convert that life to revolutions and then to millions. It comes out to 300 million revolutions, so L is 300. The plan, threshold, factors, equivalent load, then the required dynamic rating. Solve. Part 1. Build the threshold E from the thrust ratio against the static rating. It lands at 0.298. Now the thrust test. FA over VFR is 0.333, just above E, so the thrust counts. That fixes X at 0.56 and Y at about 1.48. Notice how close the comparison is. If the outer ring had been turning, V would push the ratio below E and flip you to the Y equals 0 branch. Solve. Part 2. Assemble the equivalent load, XVFR plus YFA, about 1,580 pounds. Feed that into the life law, with life at 300 million revolutions. For a ball bearing, the required dynamic rating is roughly 10,600 pounds. Swap in the roller exponent of 10/3, and the same duty needs only about 8,760. The higher exponent makes rollers more durable per pound of rating. Pick a catalog bearing rated at least that high. Traps. 5 ways this bites. 1. Life must be in millions of revolutions, not raw revs. 2. The exponent is 3 for balls, but 10/3 for rollers. Don't default to the cube. 3. V belongs inside the thrust test, as well as the equivalent load, and an outer ring rotation can flip the branch. 4. Below the threshold, Y is 0, and the axial load drops out. Don't force a thrust term. 5. Keep the static rating C0 and the dynamic rating C straight. One sets the factors, the other is what you solve for. Quick recall. Rolling bearings size by the load-life law. Rating equals load times life to the 1 over A, with a 3 for balls and 10/3 for rollers. For a combined load, first convert to an equivalent radial load. The rotation factor V and a single threshold E set the X and Y factors. Journal bearings run on a different model entirely, Petrov's friction relations. Golden rule: convert to the equivalent load first, then apply the life law, and remember, C0 is static. It only sets the thrust factors. Next up, Lesson 3. Power screws. The shaft now turns in properly sized bearings. A power screw takes that rotation and turns it into a straight-line force, the heart of a jack, a press, or a lead screw. Lesson 3 builds the torque to raise and lower a load, the mean diameter and lead angle geometry, and the collar friction term that decides whether the screw holds or backs off. Everything's at pprepengine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at pprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.